Welcome back, everyone. In today's video, we're solving one of the most popular interview questions on LeetCode. Problem number 20, valid parentheses. This is an easy-level problem, but don't underestimate it. Companies like Amazon, Google, Microsoft, and many others frequently ask variations of this question because it tests your understanding of the stack data structure. By the end of this video, you'll understand the intuition, algorithm, Python solution, dry run, edge cases, and time complexity. So let's get started. Let's first understand the problem. You're given a string containing only 6 possible characters, parentheses, square brackets, and curly braces. Your task is to determine whether the string is valid. A string is considered valid if, first, every opening bracket has a matching closing bracket. Second, the brackets are closed in the correct order. Third, every closing bracket corresponds to the most recent unmatched opening bracket. If all these conditions are satisfied, return true. Otherwise, return false. Let's understand with a few examples. Example 1, parentheses only. We open one bracket and immediately close it. That's valid. Example 2, different bracket types are opened and closed correctly. Also valid. Example 3, we encounter a closing square bracket without opening one first. That's invalid. Example 4, the brackets are properly nested. Valid again. Finally, the closing parenthesis appears before the opening square bracket is closed. The order is wrong, so the answer is false. Before designing our solution, let's look at the constraints. The string length can be up to 10,000 characters. This means we should avoid nested loops whenever possible. An efficient linear time solution will work perfectly here. To solve this problem efficiently, we need a stack. A stack follows the last in, first out principle. Imagine stacking books. The last book you place on top is the first one you remove. There are only 2 main operations. Push means inserting an element. Pop means removing the top element. Since brackets close in reverse order of opening, stack becomes the perfect data structure. Here's the main idea. We scan the string from left to right. Whenever we see an opening bracket, we push it onto the stack. Whenever we see a closing bracket, we compare it with the top element of the stack. If they match, remove the opening bracket from the stack. If they don't match, or the stack is already empty, the string is invalid. After processing every character, the stack should be empty. If it isn't, there are unmatched opening brackets. Let's visualize the process. Opening brackets are pushed one by one. The newest opening bracket always stays on the top. Whenever the correct closing bracket appears, we simply pop the matching opening bracket. This continues until every bracket is matched. That's exactly why stack works so well here. Instead of writing multiple if-else statements, we'll use a dictionary. It stores which opening bracket belongs to each closing bracket. Closing parenthesis matches opening parenthesis. Closing square bracket matches opening square bracket. Closing curly brace matches opening curly brace. This makes the code shorter, cleaner, and much easier to understand. Let's summarize the algorithm. Step 1, create an empty stack. Step 2, create a dictionary for bracket matching. Step 3, traverse every character. If it's an opening bracket, push it. Otherwise, check whether the stack is empty. If yes, return false. Compare the top element with the expected opening bracket. If they don't match, return false. Otherwise, pop the stack. Finally, if the stack is empty, return true. Otherwise, return false. Now let's convert the algorithm into Python. We initialize an empty stack. Then we create our dictionary of matching brackets. Next, we iterate through every character. Opening brackets are pushed onto the stack. For closing brackets, we first check if the stack is empty. Then we verify whether the top element matches. If not, return false immediately. Otherwise, pop the matched bracket. At the end, we simply return whether the stack is empty. That's the entire solution. Let's dry run the input. Opening parenthesis, push, opening square bracket, push again, closing square bracket. It matches. Pop, closing parenthesis. Again, it matches. Pop. The stack is empty. Therefore, the answer is true. Now consider another example. Opening parenthesis. Push. Opening square bracket. Push. Next, we see a closing curly brace. The top of the stack contains an opening square bracket. They don't match. So we immediately return false. There's no need to continue checking the remaining characters. Let's analyze the complexity. Every character is processed exactly once. Therefore, the time complexity is O of n. In the worst case, every character could be an opening bracket, so the stack stores all of them. Therefore, the space complexity is also O of n. This is the optimal solution for this problem. Let's discuss a few important edge cases. A single opening bracket is invalid. A single closing bracket is also invalid. All opening brackets without closing brackets are invalid. All closing brackets without opening brackets are invalid. Proper nesting, like opening curly brace, opening square bracket, opening parenthesis, followed by their correct closing order, is completely valid. Always test your code with these cases before submitting. During interviews, don't jump directly into coding. First, explain why stack is the right choice. Then, describe your algorithm clearly. Walk through one valid example. Then explain one invalid example. Finally, mention the time complexity and space complexity. This structured explanation creates a strong impression during interviews. And that's how we solve LeetCode 20, valid parentheses using a stack in Python. If you found this video helpful, don't forget to like the video, subscribe to the channel, and hit the notification bell. Also, let me know in the comments which LeetCode problem you'd like me to explain next. Thanks for watching, and as always, keep practicing, keep learning, and happy coding. See you in the next video.